Encapsulation is one of the forming principles in object-oriented programming. It refers to the idea of binding an object state and behavior together in one unit. In one word, encapsulation is about wrapping data and code acting on that data together. This may sound familiar, and it should. In the last chapter, we bound together data and methods in form of a Java class. Now we are giving this idea a formal name, encapsulation. While we saw the beginning of how to perform encapsulation by pure organization of the code in this chapter, we will expand upon that concept as well as look at some of the benefits of this approach. One benefit is we can prevent classes from being tightly coupled. This means we can easily modify one class either in the data it contains or its behaviors without affecting the rest of the program. However, this can only happen if we have a clear interface between the class and the rest of the program. Everything can't have direct access. We will need to restrict some of the components of a given class. In the last chapter, we directly accessed the tree type attributes along with other attributes of the tree class. If the name of this attribute or the way it's stored changed, the classes using this attribute would likely to need to change too. To make our program more robust to changes, we can make class attributes hidden from other classes using encapsulation. The data would still be accessible but only directly through the methods of the class. This would allow us to create a specific pathway for the classes to communicate without making them heavily dependent on each other. By preventing other classes from having direct access to a certain attribute, our program become more secure and less error prone because when a given change has to be made, it will result in less code changed. Furthermore, with more restricted access, it's less likely than an attribute would be overwritten with an invalid value or null unexpectedly.